Hello everyone, we are going to start our computer network course with the introductory chapter. The textbook that we are going to use throughout this course is Computer Networking, a Top-Down Approach by Jim Kruse and Keith Ross. The goal in this chapter is to get a feel about computer networking, to an understanding of the big picture, and to learn about certain terminology. Of course, later throughout the course, we are going to go into details about these topics. And here is the roadmap that we are going to follow throughout this chapter. First, we are going to talk about what the internet is and what a protocol is. Then we are going to talk about the topics that are related to network edge, such as host, access networks, and physical media. Then we are going to talk about certain technologies that are at the heart of the network core, such as packet and circuit switching, the internet structure. Then we are going to learn about certain important terminology related to performance, such as loss, delay, throughput. And of course, we are going to talk about protocol layers, service models, and security. And then we are going to take a brief look at the history of computer networking. Here is a nuts and bolts view of the internet. There are billions of connecting computing devices that are connected to the internet. These are called host or end systems. These systems are running network applications at the internet edge. So what are these hosts or end systems? Well, your smartphones, your laptops, smart appliances, desktops, servers, or equipment, or other types of devices in data centers, even smart traffic lights and smart cars, they are all end systems or hosts that are connected to the internet. And there are packet switches that actually help us to forward packets, chunks of data. Now, there are two main types of devices, such as routers and switches. Now, these icons over here where you see are a common notation in computer networking. So whenever you see a network related diagram, you may assume that these are devices that are used for packet switching. And we are going to talk about what routers and switches do. Now, of course, these devices are connected to each other via certain links. We may have fiber or copper, we may have radio, and we may have satellite. Now, when we talk about communication links, we have to learn about certain important concepts such as transmission rate or bandwidth, so that we can talk about the effectiveness and efficiency of our networks. And of course, the internet consists of networks such as mobile networks, home networks, enterprise networks, or data center networks. And these are managed by organizations or by ourselves in our home networks. Now, there are many devices that are connected to the internet, such as internet phones, gaming devices, security cameras, appliances such as refrigerators that are connected to the internet, Amazon Echo, IP picture frame, or devices that monitor energy uses may be connected to the internet. And of course, cars, bikes, scooters, pacemakers, monitors, AR devices, Fitbit, and even diapers in some way may be connected to the internet. And we may have web-enabled toasters that can help us to learn about the weather. And of course, there may be many other devices that may be connected to the internet. Now, actually, the internet is a network of networks that are connected through each other using via internet service providers. We may have local and regional ISPs, internet service providers, and we have national or global ISPs that connect countries or continents. Now, the internet works with protocols, and protocols are everywhere. And these protocols helps us control sending and receiving messages. And HTTP, Hypertext Transfer Protocol, such as web, streaming video, Skype, TCP/IP, Wi-Fi, 5G, 4G, 5G, there are even we are talking about 6G and 7G and Ethernet are all examples of protocols that govern the exchange of data in the internet. And we are seeing the links over here, such as IP, streaming video, 4G, Skype, Ethernet, HTTP, TCP, and Wi-Fi. We are going to learn about these protocols. Now, how are these protocols are developed and governed? Well, the internet standards called requests for comments are the governing mechanism for protocols, and IETF, Internet Engineering Task Force, is responsible for ensuring that these RFCs are developed and they're published and they're maintained. So there's a mechanism over there that helps us govern the internet. Let's take a look at the internet from a services view. For many users, the internet is about accessing a web page or playing video games with friends, e-shopping, social media. So most users are actually caring about the services that they're getting from the internet. In that sense, the internet is the infrastructure or forms the infrastructure that provides services to applications such as web, streaming video, multimedia teleconferencing, email, games, e-commerce, social media. Via protocol, the internet provides the programming interface to distribute the applications. Now, these are like hooks, allowing sending and receiving applications to connect to the internet and use the internet transport service. And also, they provide service options. So this is analogous to postal service. You may get to the post office and you may request certain different services, such as first-class mail, such as priority mail, regular mail, or medium mail. Now, the postal office does not actually care about what's inside the package, but they will try to match what you request in terms of service. So if you want first class mail service, then they will try to provide that mail. So let's say you are at this workstation and then you request the Amazon website from the Amazon Web servers. So the infrastructure will provide you the web page to you, but these routers, switches, and other devices do not actually care what's inside those packets, but they will try to match the service that you request and bring you the Amazon website. By now, we mentioned the term protocol for a couple of times, and we are going to talk a lot about protocols throughout this course. So let's take a look at what a protocol is. Now, humans use protocols all the time. Whenever we ask what the time is, the receiver will respond in a particular way. We may start a conversation by saying, I have a question. And of course, introductions are a form of protocols. Now, protocols are rules for specific messages sent and specific actions taken when message received or other events. So what about network protocols? Well, network protocols are between computers and devices rather than humans, and all communication activity in the internet is actually governed by protocols. So the formal definition of protocols is protocols define the format and order of messages sent and received among network entities and actions taken on message transmission and receipt. Now you'll see that most computer networking is about protocols, and we will discuss various protocols at various levels throughout this course, and protocols will be the one of the biggest portions of this course, and we'll learn a lot about it. So let's take a look at an example of a protocol. Now let's say Alice says hi to Bob, and Bob responds with a hi. Alice asks, got the time? And Bob responds such as 2 p.m. So here's an example between a computer and a server. And let's assume we're sitting on our desktop and we request a web page from a web server. And basically we initiate the conversation, the computer conversation, with a TCP connection request. And we got a response such as TCP connection response. And we will request a web page. In this case, this is the web page of one of the authors. and then the web server will send a file that our browser is going to show or view on our computer. Now we are going to learn about what the TCP means over here, and we are going to learn about when we use GET and how web pages are sent or exchanged between computers. Let's talk about the network edge. Let's take a closer look at the internet structure. Now on the network edge, we have hosts. These are clients. As you can see, we may have desktops, we may have laptops, and we have servers. This is in our enterprise network. We may have servers such as DNS servers, web servers, and so forth. And in data centers, we have some other types of servers. So these are host or end systems on the network edge. Now, how do we access to the internet? Well, we can access internet through wired links. And over here we have wired links. And over here we have wired links. And we can also access the internet via wireless links, such as over here and such as at our homes through the wireless routers. And at the network core, we have interconnected routers, which helps us to form a network of networks. Let's talk a little bit about access networks and the physical media. Now, in the picture, we are seeing various types of networks that are connected to the internet. And for example, here's a residential access network. This may be our home network. And here's a mobile network. And here is an enterprise network, such as universities or a school or a company's network. And here's a network for a data center. Now, these systems are connected to the internet through edge routers. And we are seeing edge routers circuit over here. Now, in home network, these two devices are shown, and we'll talk about why is that. And in an enterprise network, we may have multiple edge routers that will help us to connect in multiple ways. So this is an example of how various networks are connected to the internet. Now, this is one of the most common types of access to the networks, to the internet actually. So this is called cable-based access, and here's our cable. Now, normally this is a fiber optic cable, and this cable is actually shared, maybe shared by multiple homes. And we have a cable modem over here, which is connected to our desktop, and we may have a TV that we get streaming TV service, and now we have a splitter. Now, in this cable, in fiber optics, we may have what we call frequency division multiplexing, FDM. So different channels transmitted in different frequency bands. So here we have channel 1 to channel 9, and video on channel 1 is transmitted at this frequency, and video on channel 6 is transmitted at this frequency. Now, this frequency is higher than this frequency, and we may have, now these may be related to our streaming video service, and this may be related to data which when we access the web or when we exchange emails, and we may have another channel for controlling the network and so forth. And these are connected to what we call the cable head end. Now, the number of channels we may have over a cable is dependent on the quality of the equipment that we are using, because the higher frequencies that we can achieve, then we may have more multiple channels that we can attach multiple home networks, that we can increase the channels, so we can generally increase the access to the internet. Now, here is a detailed picture of access. Now, data and TV transmitted at different frequencies over a shared cable distribution network. Now, this is a shared cable distribution, and this is attached to cable head end, which is called cable modem termination system. And now this is connected to the internet service providers. Okay. So we also have a certain type of access to the network, such as hybrid fiber coax, coaxial actually. Coax is short for coaxial. Now, in this type of network, in this type of architecture, we both use fiber optics and coaxial at the same time. So when the network is coming to the residential area, we use fiber access, which will provide us higher bandwidth. And then when we are sharing this internet structure to the home network, then we are using coaxial. So we can achieve up to 40 megabits to 1.2 gigabits per second downstream transmission rate and 30 to 100 megabits per second upstream transmission rate. Now, the network of cable and fiber attaches home to ISP router, and homes share access network to the cable hand. And right now we are seeing that these homes are sharing the cable access network to the cable hand. Now here is an example of another type of access, which is called digital subscribing line, DSL. Now this is a little bit more older technology. Right now, well, there are in certain areas the DSLs may be used, but DSL has a lower transmission rate compared to cable modem. And again, this is an example of our home network. Right now we have a DSL modem, digital subscriber line modem, and again we have a splitter. And now here this is connected to our telephone, right? Telephone system. And now this both voice and data transmit at different frequencies over dedicated line to the central office. So the difference between the cable access and DSL access is that each home needs to be connected to the central office through a dedicated line. And here's another home, and this home has a dedicated access to the central office, which we have a DSL access multiplier, digital subscriber line access multiplier. Now, after at the central office, this voice and data is actually divided into various frequencies, and that will be sent to the telephone network, and the data will be sent to the ISP routers, internet service providers routers. So the voice goes to telephone network, the data goes to the internet. So the advantage of DSL was using existing telephone lines to central office that has the digital subscriber access multiplexer, and data over DSL phone line goes to the internet, and voice over DSL phone line goes to the telephone net. Now, the advantage of the DSL was at the time we didn't need to construct a lot of infrastructure. We could have just used the telephone lines to access the internet. But right now we built the infrastructure for cable modems. So therefore, we can now achieve up the higher speeds. DSL is a little bit older technology compared to the cable modem access. The transmission rates we can achieve with DSL is around 24 to 52 megabits per second dedicated downstream transmission rate, and 3.5 to 16 megabits per second dedicated upstream transmission rate. As we mentioned, the transmission rates we can achieve with DSL is a little bit limited compared to the cable access. Now here is an example, detailed example of home networks, and we have access to and from headend or central office. And here's our cable or DSL modem, and here's our router, which may have applications, or which may have software for firewalls and network address translation service, and we'll talk about what these are later on throughout the course. And then we have a wired Ethernet access, which can achieve to 1 gigabit per second. So this desktop is connected to our router. And then we may have a Wi-Fi wireless access point, which can achieve speeds up to 450 megabits per second. And we may have our smartphones, we may have our mobile mobile devices, or we may have our laptops, and we may have another desktop, and we may have our smart appliances such as our refrigerator. Now, these devices may now be combined in a single box. Why are they shown in different as different equipment? Because in the past, these were sold separately due to its prices, and when there weren't a lot of wireless devices, some people, actually most people, weren't buying Wi-Fi wireless access points. So, and the electronic equipment prices was high, so the manufacturers were selling this separately to bring the prices down. As the electronic equipment prices go down, and as many people would now require access through wireless, so they combine these in a single box, and right now the prices are cheaper, so many people are now can now access to it. But in certain older networks, you may see that these are separate in different as different equipment or as different boxes. Now let's take a look at wireless access networks. Wireless access networks are shared networks. Now these networks connect end systems to routers via base stations, also called access points. Wireless local area networks, also called VLANs, works typically within or around a building. It's about 100 feet. And of course, these are affected by the obstacles in the environment. And the protocol that we are using for wireless access networks are 802.11bgn. These are also called Wi-Fi, and BGN are variations of this protocol, and these are coming from an IEEE standard, such as IEEE 802.11. Now, the transmission rates we can achieve, depending on the version, such as BGN, is 11, 54, and 450 megabits per second. And here's an example. In our home network, we may have laptops, we may have appliances, or we may have even our smartphones. Now they are connected to a wireless router, which is connected to a modem, and then we are connected to the internet. Another type of wireless access networks is wide area cellular access networks. Now, when you go out, when you have your smartphones, you are accessing the internet through your smartphone. And these are provided by mobile or cellular network operators, and they can achieve ranges up to 10 kilometers, and they can achieve speeds up to 10 megabits per second. Now, generally right now, we are achieving 4G and 5G. G means generation, fourth generation and fifth generation. And we are not right now even talking about 6G or 7G. So as technology progresses, we are achieving newer generations with higher speeds. And in these, here's our tower, and your smartphone is accessing internet to this tower. And of course, your laptops or your smart cars or your autonomous cars may access these wide area cellular access networks. We also have enterprise networks. Enterprise networks are the networks that we use in companies, universities, or school or similar institutions. These are a mix of wired and wireless link technologies, and they're connected through a mix of switches and routers. And we are going to cover the differences between switches and routers. Now, using Ethernet, or here in the picture, we can see Ethernet switches. We can achieve wired access speeds at 100 megabits per second, 1 gigabit per second, or 10 gigabit per second. Also, we may have Wi-Fi, and then we may be connected to the wireless access points via our laptops. And with wireless access points, we can achieve speeds such as 1154 or 400 megabits per second. And now, of course, using these switches, we are connected to a router, an edge router, which is connected to an enterprise link to an ISP, internet service provider, and these are also called institutional routers. Of course, these are a little bit with more capacity compared to home routers because they are many clients, many hosts or end systems are connected to this router. They are connected to the internet, and of course, we may have in enterprise networks, we may have institutional web servers or mail servers. They are also called exchange servers, and depending on the organization, we may have the DNS servers, and there are some other types of servers that we have in enterprise networks. Another type of access networks we are seeing today are data center networks. In the picture, you are seeing data center networks behind content provider networks such as Google, Amazon, or some other big companies. And in these data center networks, we have high bandwidth links, which can achieve to 10 to 11, 10 to 100 gigabits per second. These are connected with hundreds and or thousands of servers together and to internet. And in the picture, we are seeing an example of a data center network, which is this picture is from the Massachusetts Green High Performance Computing Center. And sometimes, due to the cooling need of these high performance servers, right now these data centers in metros may even be in certain areas that has low electricity prices, or even undersea due to cooling and similar requirements for that. And here is one of the Microsoft's underwater data centers, and this is news from Microsoft, dates back to 2020. And the news says that Microsoft finds underwater data centers are reliable, practical, and use energy sustainable. How hosts send packets of data? Let's take a look at the host sending function. Now, in our end systems, such as your laptop or even your smartphone or your desktop, the host sending function takes the application message and breaks it into smaller chunks known as packets, which has L length bits, and transmits packets into access network at transmission rate R. And these are also called link transmission rate, also known as capacity or link bandwidth. And here is the formula for it. The packet transmission delay, also the time needed to transmit L bits packets into links, which is equal to L over R. L is the number of bits, and R is the bits per second. And here is a picture depicting the operation. This is your desktop, in your application such as your web or such as your email or such as Skype or another kind of networking application. Now in your computer, in your desktop, these are divided into in this particular example into two packets. Each of has L bits in it, and then this is transmitted over the link over here to our router. This may be our edge router, and the link's capacity R, which is also called the link transmission rate. Let's talk a little bit about the physical media, which consists of our links. Now we have certain terminology related to the physical media, and we have bit, which is short for binary digit. These are the smallest unit of information in computing systems. Now these information, the smallest unit of information, is propagated between transmitter and receiver pairs. And we have physical links. These are what lies between the transmitter and receiver. And we have guided media or unguided media. In guided media, the signals propagate in solid media such as copper, fiber, or coaxial. And then we have unguided media. In unguided media, the signals propagate freely, such as radio. These are generally what you may remember from Wi-Fi and other types of unguided media or environments. Now, here's an example for a guided media. We have twisted pair. In a twisted pair, we have two insulated copper fibers. Of course, depending on technology, we may have different categories. Right now, we have category 5 or category 6. When you go to your favorite electronics store, these cables are known as Cat5 or Cat6 cables. They are short for category 5 and category 6. Of course, they have different speeds, and with the when you have more numbers in the category, you may generally assume that it will achieve higher speeds. With Cat5 cables, you will have 100 megabit per second to 1 gigabit per second Ethernet, and with Cat6 cables, you may achieve up to 10 gigabits per second Ethernet. And here are the examples for these twisted pair cables. And as you can see, there's a little bit twist on each pair. That's why they are called twisted pairs. And these are where you connect these cables to your laptops or to your desktops or to your switches, routers, and so forth. And when you look at these closely, you'll see that there are eight wires that's going in, and we'll learn about these technologies later on. And here's another type of physical media, which is the coaxial cable. In coaxial cables, we have two concentric copper conductors. And in the picture, you can see that there is a wire in the middle, and it's insulated with plastic. And there's coating over here, and there's another extra set of extra wires. Now these are bidirectional, and they are used in broadband. It may have multiple frequency channels on the cable, and it can achieve 100 megabits per channel. And we have fiber optic cables. Now, fiber optic cables are better technology compared to coaxial cables. With coaxial cables, we need to use repeaters as signals propagate through coaxial cables. There will be loss, so at certain distances, we may have to use repeaters. These repeaters amplify the signal to achieve higher distances. But with fiber optic cable, in the fiber optic cable, we have, and here's an example of it. These are like glass links over here, and light propagates within glass. So the signal loss compared to coaxial cable is less. So we can achieve higher lengths, and the repeaters that we have to use is less compared to coaxial cable networks. Now, in fiber optic cables, we have glass fiber carrying light pulses. Each pulse is a bit, and we may achieve high-speed operation that can achieve 10 to 100 gigabits per second. And compared to coaxial cables, we have low error rate, and repeaters are spaced far apart. And the reason that we have low error rates is that they are immune to electromagnetic noise. Coaxial cables are not immune to electromagnetic noise, and noise over time degrades the signal. Therefore, we need to use repeaters to amplify the signal. That's why fiber optic cables are a better technology compared to coaxial cable. Now let's take a look at unguided physical media. And in unguided physical media, we have wireless radio. In wireless radios, the signals are carried in various bands in the electromagnetic spectrum. Of course, we have no physical wires, and we can broadcast our information and in half duplex mode from sender to receiver. And the propagation environment has some effects that we have to be aware of, such as reflection, obstruction by objects, interference, and noise. In reflection, some of our signals may be reflected back, which may reduce our efficiency. and if there are objects obstructing the way the signals are propagated, the signals will not reach to the receiver. And if there are interference or noise, we may lose some information in the signal. That way we may have to retransmit that information again. Let's take a look at what half duplex and full duplex means. And here's an example for half duplex communication. We have two radios, and in half duplex, only one radio can transmit at a time. And this is the sender, and this is the receiver. And only the sender may send the communication. And of course, in going back, only the receiver will send back some feedback to the sender. Now, in full duplex, both radio devices can transmit at the same time, and this way we can achieve higher communication rates. So full duplex is better than half duplex naturally. And here are various radio link types. We have wireless LANs, wide area, Bluetooth, terrestrial microwave, and satellite. With wireless local area networks, wireless LANs, Wi-Fi, we also know as Wi-Fi, we can achieve 10 to 100 megabits per second, and the distance is about tens of meters. In wide area networks such as 4G, 5G, cellular, we can achieve speeds up to tens of megabit per second. With 4G, 5G, it's a little bit higher. With 6G and 7G, 7th generation, we will achieve higher speeds, and this can go over 10 kilometers and maybe more depending on the environment that we are in. And we have Bluetooth, and this is a cable replacement. It works in short distances with limited rates. Therefore, we are using them for attaching our mouses or keyboards. And we have terrestrial microwave. This is a point-to-point link which can achieve 45 megabits per channel. And we have satellite links. Now with satellite links, we can achieve close to 100 megabits per second with Starlink, downlink. And there is in the satellite links, there's considerable end-to-end delay because the signal will have to go to geostationary satellite, and that takes time because those satellites are up in the air over many kilometers, and we may observe 270 milliseconds delay. Now this may not be high in terms of human understanding, but in networks this is a little bit delay because we may need much higher speeds in certain communications. That's why, but the satellite has a much broader coverage. That's why it's a good alternative, but we have to consider the delay when we are using satellite links. In this lecture, we talk about the internet, what it is, and we learned that internet is actually a network of networks. And we also talk about protocols, what a protocol is, and by now we know that protocols are everywhere, and throughout the course we are going to examine many different protocols that are governing the internet, that are governing the networks. And we also talk about there are many different types of hosts, and there are various types of access networks such as mobile networks, such as home networks, enterprise networks, and data centers networks. And we also talk about physical media, various types of physical media. We have guided and unguided media. With guided media, we are using various types of wires, and the physical media is a wired media with guided media. And we have talked about twisted pairs, we have talked about coaxial cables, we talk about fiber cables, and we learned that fiber cables are a better option to others because the signal loss is much less compared to other types, and it can achieve higher distances. We may have to we can use less repeaters compared to other types of guided media, other types of wired media. We also learned that there is unguided media such as radio, and there are various types of unguided media such as Wi-Fi, such as satellite links, such as terrestrial microwave, and we have Bluetooth, which we can use in short distances. Each of these different technologies offer different speeds, and they have various types of limitations and various types of strengths compared to each other. And of course, the price range changes based on the technology that we are using. So we, in designing networks, we are going to consider these factors in establishing or in constructing the networks that we need. And now we are going to talk about network core. We are going to talk about packet and circuit switching and internet structure in the following lectures.